So this is 6.2. We're going to talk about transforming and combining random variables. So linear transformations. In Chapter 2, we studied the effects of transformations on the shape, center, and spread of a distribution of data. We talked about if you wanted to add or subtract a constant to every single piece of data, that would add or subtract from the measures of center, the median and the mean, that it does not change the shape or the spread, so the range, the IQR, the standard deviation, all stay the same. So when you add, it changes the mean. It does not change the standard deviation. Adding changes the median, but it does not change the range or the IQR. Multiplying or dividing changes everything. It will either multiply or divide the measure of center, and it will multiply or divide the measure of spread. A lot of the examples for today on your notes are going to be filled in, so we can just kind of do more of a discussion and talk about what the numbers mean. Okay. So we have this Jeep tour example, and we're going to kind of use this example throughout the entire lesson. So we have Pete's Jeeps Tours, and he offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. The number of passengers, X, so X represents the number of passengers, on a randomly selected day, has the following probability distribution. So probability distribution has to have every member of the sample space, the probability of everything in the sample space. All the probabilities have to be between 0 and 1, and they have to add to 1. So my distribution has number of passengers from 2 to 6, and it has the probability that he's going to have that number of passengers on that day. We have found the mean, so mu sub x is 3.75, and the standard deviation of x is 1.0897. Notice I went 4 decimal places because I don't like decimals that start with a 0. Remember that you have to be accurate to 3 decimal places, but when there's a 0, I always go 4. So I would love it if you would kind of make that a habit. So on a randomly selected day, the number of people on the trip would be, on average, about 3.75 and would typically vary 1.09, if we chop it, passengers from the mean. That's a sentence that you need to be able to write, and it's just describing the mean and the standard deviation. Now, let's make this a little bit more interesting. Pete charges $150 per passenger. We have a new variable. Let C equal the total amount of money that Pete collects on a randomly selected trip. Write a probability distribution for C and find the mean and the standard deviation of C. All right, so in my chart, I have total collected. You could just have a big fat letter C. And I'm not going to start with $150 because he's not going to go for one person. He's only going to go for 2 people. So that's 300 all the way up to 6 people, and 6 times 150 is 900. The probability that he's going to get that much money is the same as the probability of the number of people that are going to come. So if there's a 15% chance that he could have 2 people, then there's a 15% chance he's going to bring in $300. So this is C, total money collected, and its probability. So this is a probability model. Now, it says find the mean and the standard deviation. Okay, well, mu sub C is going to be 150 times mu sub x. I'm multiplying every single x by 150, and that is going to change my mean and my standard deviation, because multiplying by a number, by a constant, changes the mean and the standard deviation. Now on an FRQ, you would have to show all 3 lines. And I know some of you can just go straight to here, and do what's written out in your head, but it's all about being able to communicate that to the grader. So I'm showing, first of all, with correct notation. So mu sub c, the average of the money collected, equals 150 times the average or the mean of the number of passengers. And then I plug in my numbers, and then I get my value. Same thing here. Sigma sub c is 150 times sigma sub x, 150 times the sigma, and so there's my sigma sub c. So now I'm going to write my sentence. On a randomly selected trip, the total amount of money that Pete collects is, on average, $562.50 and will typically vary by about $163.46 from the mean. Now this is money, so I went 2 decimal places, but I showed in my work all the decimal places. Okay, so you guys can see that we're using a probability model. We're using the fact that we know that multiplication changes the mean and the standard deviation, and we're putting a nice big fat bow on it with our sentence, our conclusion. Okay, well, Pete's bringing in some money, but it's also costing him money to run these tours. So it cost Pete $100 to buy permits, gas, and a ferry pass for each half-day trip. So now we have a new variable, V. The amount of profit V that Pete makes from the trip is the total money collected minus $100. Now pay close attention to the variables that I'm using. V equals C minus 100. So C is how much he's collected minus 100. Now, I hope some of you are already thinking, well, could I have related this back to X? And X is the number of passengers. Absolutely. V equals 150X minus 100. 150 times each person, and then minus 100 off the top, because that's how much it's going to cost him. So, but our V is going to relate it back to the total amount collected. Write a new probability distribution for V and find the mean and the standard deviation for V. Okay, so I'm taking my C values, which were 300, 450, 600, 750, and 900. Those were my C values. And I'm subtracting 100 from each trip, because that's how much it's going to cost him. Again, the probability stays exactly the same, because this is the probability that that many people will come on this trip, therefore incurring this amount of charges. Now, I'm subtracting $100. That is going to change my mean, but it will not change my standard deviation. Adding and subtracting does not change the spread of your data. So notice the notation, correct notation. This is mu sub V equals mu sub C minus 100. There's my mu sub C minus 100. There's my total for my, what does V stand for? Profit. Now sigma sub V is going to equal straight up sigma sub C. It does not change with addition and subtraction. And that little boxed in piece of information that I wrote right there, that is a wonderful thing to write when you're writing on an AP exam, because you are communicating to the grader why you didn't subtract 100. It is not necessary, but it is a wonderful little nugget to give them to instill confidence in your work as they're grading it. So then we're going to write our beautiful sentence, which is the big red bow on top. On a randomly selected trip, Pete will make a profit of $462.50 on average, and his profit will typically vary by about $163.46 from the mean. So the kicker here is make sure you know correct notation. Make sure you know what changes what. multiplication and division affect everything. Addition and subtraction only affect mean. They do not affect the standard deviation. Okay, and we kind of alluded to this earlier. Could we have gone directly from the number of passengers X on a randomly selected Jeep tour to Pete's profit V with the equation V equals 150X, which represents C, minus 100, or V equals negative 100 plus 150X. This linear transformation of the random variable X includes both the transformations we performed. All right, so let's talk about this in general. If y equals a plus bx, so something has been multiplied to x and something has been added to x, it's a linear transformation of the variable x, then the probability distribution of y has the same shape as the probability distribution of x, has the same shape. It doesn't have the same spread, it doesn't have the same mean, but it does have the same shape. If it's symmetrical, it will still be symmetrical. If it's bimodal, it will still be bimodal. If it's skewed right, it will still be skewed right. All right, the mean of y takes into account both transformations to the mean of x, but the standard deviation of y only takes in the multiplication factor for the standard deviation of x. The bottom two rules don't just apply to means and standard deviations. Linear transformations have similar effects on other measures of center or location. So median, quartiles, percentiles are all the same thing. They are affected by multiplication and they are affected by addition and subtraction. The spread, if I was talking about IQR or range, those would also only be affected by multiplication because they are a measure of spread. These rules apply to both discrete and continuous random variables. All right, so here is Pete, and this is the mu sub x and the sigma sub x. Now this is sub x, and x is the number of passengers. So profit is going to equal negative 150 or negative 100 plus 150x. This was later defined as C, but we're again going to put it back in terms of x's. So mu sub v is negative 100 plus 150 times mu sub x. That's where mu sub v came from. Sigma sub v, that should be a v, is 150 times sigma sub x. Should be a v. So sigma sub v only got only multiplied 150 by the sigma sub x. It did not subtract the 100. Just make sure you're super clear on what changes what. Okay. A large auto dealership keeps track of sales made during each hour of the day. Let X equal the number of cars sold during the first hour of business on a randomly selected Friday. Let X equal the number of cars sold during the first hour of business on a randomly selected Friday. Based on previous records, the probability distribution of X is as follows. Okay, so again, this is the first hour of business on a Friday. We have cars sold, 0, 1, 2, or 3, and we have the probability that we're going to sell that many cars. Random variable C has a mean of 1.1, standard deviation of 0.943. Suppose the dealership's manager receives a $500 bonus from the company for each car sold. Let Y equal the bonus received. Find the mean and the standard deviation. Well, that's multiplication. So 500 times however many cars they sell. So that is going to affect the mean and the standard deviation. So here's my transformation. All right, here's my correct notation. Mu sub Y equals 500 times, not sigma, times mu sub x, which is the 1.1, And sigma sub y equals 500 times sigma sub x. Okay. To encourage customers to buy cars on Friday mornings, the manager spends $75 to provide coffee and donuts. The manager's net profit T, new variable, on a randomly selected Friday is the bonus earned minus this $75. Find the mean and the standard deviation of T. Okay, now I have two versions of this. I have this one and I have this one. I want you to take a second and make sure you understand that they are both saying the exact same thing. Focus on your variables. X is the number of cars. So times 500 and then minus the 75. This is total profit. Now Y already includes the bonus. So this is the total profit based on the bonus, which is 500x. I like this one because it shows both in it. I don't have to remember what Y stands for. The 500 is going to affect the mean and the standard deviation. The minus 75 is only going to affect the mean. Okay, so look through what's written in blue and make sure you're good. Okay, the baby and the bathwater. One brand of bathtubs come with a dial to set the water temperature. When the baby safe setting is selected and the tub is filled, the temperature X of the water follows a normal distribution with a mean of 34 degrees Celsius and a standard deviation of 2 degrees Celsius. Define the random variable Y to be the water temperature in degrees Fahrenheit when the dial is set on the baby safe. Find the mean and the standard deviation of Y. Okay, so X, let's look at our variables first. X is the temperature of the water in degrees Celsius. Y is the water temperature in degrees Fahrenheit. Here is my formula to convert Fahrenheit or Celsius to Fahrenheit. So if I change this into my variables, and I can just write this, temp of water in degrees Celsius, temp of water in degrees Fahrenheit, just so I don't get confused. So now I'm going to take this formula and I'm going to put it in terms of my variables. So Y equals 9/5 X plus 32. Now, I know that the mean is 34 degrees. Okay, well, I want you to be able to write this correctly. So that is mu sub X, because that's in Celsius. So don't just write mu, because I have two different variables here. So mu sub X is 34 degrees, and sigma sub X is 2 degrees. I want the mean and standard deviation of Y. So I'm looking for mu sub Y and sigma sub Y. Notation is really, really important. Okay, so to find mu sub Y, both the multiplication and the addition are going to be factors here. So it's going to be 9/5 times mu sub X plus 32. So mu sub Y, 9/5. All right, mu sub X was 34. Type that into my calculator, and I get 93.2 degrees Fahrenheit. Now, sigma sub Y is only going to take into account the multiplication. Addition does not change spread, because it adds 32 to everything. So everything's moving up the same amount. So it's not going to affect the spread of the data. So I'm just going to do the 9/5 sigma sub x. So sigma sub y equals 9/5 times 2. And that gives me 3.6 degrees Fahrenheit. Okay, so let's make sure we answered the question. It said find the mean and the standard deviation of y. Boom. Now, to put the nice little sentence with the bow on top, I would say a randomly selected bath will have an average typically of 93.2 degrees Fahrenheit and will typically vary from the mean about 3.6 degrees Fahrenheit. According to Babies R Us, the temperature of a baby's bathwater should be between 90 and 100 degrees Fahrenheit. Find the probability that the water temperature on a randomly selected day when the baby safe setting is used meets the recommendation. Okay, well, I have just found that the mean is 93.2 degrees Fahrenheit. They are saying you're good between 90, and I don't know where 90 would be, how far away it would be, and 100. They're saying all this is safe. And I want the probability. Well, the probability is the area under the curve. So if I find the probability, and this is in degrees Fahrenheit, so this is y. That's what I'm finding. So I'm going to normal CDF that from 90 to 100 with my mean in Fahrenheit and my standard deviation. Okay, pause this, go type it in. I got 0.784. So here's my sentence, which I would write. There is a 78.4% chance that the water temperature meets the recommendation on a randomly selected day. And really, when I write that sentence, I'm just going back and restating the question, what they're telling me to find. All right. So apparently Pete has a sister. So here we go. Pete's Jeeps and Aaron's Adventures. Recall Pete's Jeep tour probability distribution of X. And remember that X is the number of passengers. So there was that original probability model and mu sub X and sigma sub X. So again, that's back to number of passengers. So we've taken off the profit, we've taken off the amount of money he's bringing in, and we took off the cost. Okay, so this is just back to bare bones. Now, Pete's sister Erin, who lives near a tourist area in another part of the country, is impressed by the success of Pete's business. She decides to join the business, running tours on the same days as Pete's in her slightly smaller vehicle under the name Aaron's Adventures. After a year of steady bookings, Erin discovers the number of passengers Y on her half-day tours has the following probability distribution. Now, her tours can only carry from 2 to 5, and there's her probability distribution, and we went ahead and found the mean sub Y and the sigma sub Y. So that's for Erin. So Y is Erin. Y is the number of passengers for Erin. Okay, so it says, how many total passengers T will Erin and Pete have on their tours on a randomly selected day? Well, total passengers T. For any two random variables, X and Y, if T equals X plus Y, then the expected value of T is E of T equals mu sub T, which equals mu sub X plus mu sub Y. So mu sub T, so this is the average of the total, is Pete's average plus Aaron's average. So this is combining two different variables. So it's got the expected value, which we've already talked about, the expected value of the total number of passengers is mu sub T. Expected value is mu. And T is the total between Pete and Aaron. And so you're just going to add the two means together. So mu sub T equals 6.85. So the conclusion here is what we've just found. Pete and Aaron will average a total of 6.85 passengers per day. Okay, so T is our new variable and it is the total number of passengers. Pete and Aaron will average a total, average because it's a mean, a total of 6.8 passengers per day. So that's how you get the mean of combining two variables. Now let's talk about the standard deviation. Oh my. Okay, what about the variance of T? Okay, this is really, really, really important, so I'm going to slow down just a second. All right, variance is sigma squared. So sigma is the standard deviation. Sigma squared, it's called the variance. And it's just that. It's just sigma squared. It's just sigma, the standard deviation, squared. Okay? Now, I can relate two different variables, variances, together. But I cannot relate two variables, standard deviations, together. So this is founded on the variances, not on the standard deviation. Okay, so I'm thinking variances. So the variance, and that's why this is squared, the variance of the total equals the variance of Pete plus the variance of Aaron. So if that relationship is true, then to get rid of the squares, I can square root both sides. But I have to square root the right-hand side in one big chunk. I can't square root things individually. That's just an algebra thing. So when I square root the sigma sub t squared, I get sigma sub t. But this, however, I cannot square root them individually. Okay, so just a little algebra trick. If I say x squared equals 5 squared plus 3 squared, you can't square root that and say x equals 5 plus 3. That's not how that works. You'd have to square the 5, square the 3, add them together, and then root it. So you can't do that. And so that's why it is the square root of sigma squared x plus sigma squared y. And we're going to practice this, but just know that you cannot compare the sigmas. It has to be based on the variances. There's some great multiple choice questions about that. You can only find the variance of two combined random variables if they are independent. Ooh, that's another nice little catch. They have to be independent. If they're not, the variance or the standard deviation of the two combined cannot be found. Those two variables have to be independent. Now, Pete and, what was her name? Aaron. Pete and Aaron live in two different parts of the country. So they're very independent. Okay, one does not depend on the other. Find the standard deviation of T, the total number of passengers on Pete and Aaron's trip. Okay. Well, I have the standard deviation of Pete for the passengers, standard deviation of Aaron for the passengers. So the standard deviation of the total is the square root of the variances added together. And then just take a second, type that in, and make sure you're comfortable with your calculator and getting 1.441. So the total number of passengers Pete and Aaron will have will typically vary 1.441 passengers from the mean. All right, let's talk SAT scores. Okay. A college uses SAT scores as one criterion for admission. Experience has shown that the distribution of SAT scores among its entire population of applicants is such that the mass score is X, so mu sub X is a 519, sigma sub X is 115, and the critical reading, which is Y, mu sub Y is a 507, and sigma sub Y is a 111. What are the mean and the standard deviation of the total score, X plus Y, for a randomly selected applicant to this college? Well, to find the mean, I just add them together. Easy, but you have to be able to write it. So first of all, I have to define my variable because they didn't do that. So T, I define as my total score. And then I write the relationship, mu sub T equals mu sub X plus mu sub Y. They have already defined X and Y for me. I don't have to do that. Then I plug in my numbers, and then I can draw my conclusion. All of that has to be here if you want full credit. Okay. Now here's the kicker. Look what's written in black. Cannot find sigma sub T because X and Y are not independent. If I know what your SAT reading score is, then I bet I can predict your math score. I bet I can get it in the ballpark. Those two scores are related. Some people test really, really well. And so if they have a really high English score, they're going to have a really high math score. Some people freak out when they take standardized tests, and both their test scores are going to be terrible. And even if it's not extreme, if you do decent on the English, I'm going to bet you're going to do decent on the math. Now, is there going to be a difference? Absolutely, because people are usually stronger in one area than they are in the other. But if I know one of your scores, it's going to affect, I'm going to be able to know in the ballpark of how well you did on the other one. These two things are not independent. They didn't allude to that at all. They didn't say, make sure you can find it. They just threw it out there and said, hey, go find me the mean and the standard deviation. You have to remember that you cannot find a combined standard deviation if they are not independent. So that's a little spot where it can be tricky. All right, let's go back to Pete and Aaron. Earlier, we defined X as the number of passengers that Pete has, and Y as the number of passengers that Aaron has. We have the mean and the standard deviation for Pete, and the mean and the standard deviation for Aaron. Pete charges $150 per passenger. Aaron's going to charge a little bit more. She's going to charge $175 per passenger. Calculate the mean and the standard deviation for the total amount Pete and Aaron collected on a randomly selected chosen day. Calculate the mean and standard deviation for the total amount. Okay. So this is Pete, and so here's Pete, and here's Aaron. And this is based on how much they charge. So Pete's going to charge $150, so his mean is going to be $562.50. Aaron is going to be $542.50. She charges more, but she has a lower average. So the total is going to be $562.50 plus $542.50. And I would even, I know it's all written up there. I might even write that and then go there just to show them. as long as you explicitly write all this out and label it, then I think you're okay to go straight to here. I don't know. I would just dot every I and cross every T. So add those together and you get 1105. So then I have my nice little sentence. Short, sweet, get in, get out. On average, Pete and Aaron can expect to collect or earn $1,105 per day. On average, because it's a mean. Okay, and then there's that word expect, referencing again that expected value and mean are the same thing. All right, standard deviation. Well, multiplication affects the standard deviation. So here we go. Standard deviation for Pete for his earnings is $163.45, and for Aaron's earnings, it's going to be 165.025. So the standard deviation for the total is going to be the square root. Now notice there's no square on my sigma. That's why there's a square root over here. Is the standard deviation squared? That makes it a variance. And her standard deviation squared. And that gives me 232.27. So the total amount they earn together will vary, typically by about $232.27 from the mean. All right, roulette. Suppose a gambler plays 2 games of roulette, each time placing a $1 bet on either black or red. So for those of you who don't know, roulette is that big wheel in casinos that you spin the wheel and whatever it lands on, if you placed a bet on it, then you win. So they're all numbered, and then some of them are red or black, apparently. Okay, so each time placing a $1 bet on either red or black, what can we say about his total gain or loss from playing 2 games? Earlier we showed that X equals the amount gained on a single $1 bet on red or black, then mu sub X equals a negative 5 cents, and sigma, it varies about $1. Because we're interested in the player's total gain over 2 games, we're going to define X sub 1 as the amount he gains from the first game, and X sub 2 as the amount he gains from the second game. Okay, so then his total gain, T, equals X sub 1 plus X sub 2. Both X sub 1 and X sub 2 have the same probability distribution as X, therefore the same mean and the same standard deviation. What is the player's expected gain and standard deviation in the 2 games? So mu sub T equals mu sub X sub 1 plus mu sub X plus 2. And they are both the same, so negative 0.05 plus negative 0.05, which gives me a negative 10 cents. So over the course of 2 games, he's expected to lose 10 cents. The standard deviation for the total is going to be the standard deviation for the first one squared plus the standard deviation for the second game squared. So that was $1. And 1 squared plus 1 squared is 2. So the square root of 2, which is, and I'm going to put it in terms of money, $1.41. So my sentences would be the player can expect to lose a total of 10 cents in 2 games on average, but it's going to vary about $1.41 typically from the mean. I like using the word expected when I talk about the losing 10 cents because I really like this idea that the mean is the expected gain, or in this case, the expected loss. And just make sure that you reference that it's over 2 games. So when you do this, I wouldn't think about it as 2 times, because I'm playing 2 games, I wouldn't think about this as 2 times one of the mu's. I would look at it as mu sub 1 or mu sub X sub 1 plus mu sub X sub 2 instead of 2 times, because your standard deviation you also need to think of as 2 separate instances. Okay. All right, so we have added. Now let's subtract. The differences of random variables. For any two variables, x and y, d equals x minus y, then the mean of d is mu sub x minus mu sub y. So it is exactly what you think it would be. What is the average difference in the number of passengers that Pete and Aaron have on their tours on a randomly selected day? Well, Pete averages, so mu sub x. Again, remember, I'm not just using mu. I've got to denote which one I'm talking about. So mu sub x equals 3.75 passengers per trip, and Aaron is mu sub y is a 3.10. So mu sub d equals mu sub x minus mu sub y, which ends up being 0.65. So no biggie, totally cool. Here's the fun part. The variance, or the standard deviation. Variance is the squared version, which is what you see written in purple. And to find the standard deviation, I just square root both sides. For any two independent random variables x and y, if d is defined as x minus y, then the variance of d is still a plus. The variance does not change to subtraction, even when I am subtracting my random variables. So what is the standard deviation of the difference in the number of passengers that Pete and Aaron have? And it gives me Pete's sigma, and it gives me Aaron's sigma. So sigma sub d is Pete's sigma squared plus Aaron's sigma squared. So sigma sub d and sigma sub t for total should be the exact same sigma. So addition and subtraction do not change for standard deviation. It does for means, but it does not change for standard deviation. Sigma does not change to subtraction. A large auto dealership keeps track of sales and lease agreements made during each hour. X equals the number of cars sold, and Y is the number of cars leased during the first hour of business on a randomly selected Friday. So I have X's, which are cars sold, and the probability, there's mu sub X and standard deviation sub X. Y is the cars leased. So I've got mu sub Y and standard deviation, so sigma sub Y. Define D as X minus Y. Assume that X and Y are independent. That's very nice of them because I don't know if they would be independent. So they're giving us the green light because we have to be independent to find number 2. So find and interpret mu sub D, compute sigma sub D, and then it says the dealership's manager receives a $500 bonus. $300 bonus for the car lease. Find the mean and the standard deviation of the difference in the manager's bonus for cars sold and leased. All right, here we go. Number 1, find mu sub d. I'm going to write my formula first. Mu sub d equals mu sub x minus mu sub y. Plugging in my numbers. There it is. And then I have this cute little sentence. Over many Fridays, this dealership sells about 0.4 more cars than it leases during the first hour of business. Remember, this 0.4 is the difference between number of cars sold and number of cars leased. And since that's a positive value, I can conclude that the dealership sells about 0.4 more cars. And writing a sentence like that shows that you understand what you're finding. All right, standard deviation of the difference is the square root of the variances added together. So standard deviation of cars sold, 0.943 squared, plus, even though this is difference, 0.64, which is the standard deviation of the cars leased, squared. And that gives me 1.14. And that just says that typically the difference between the number of cars sold and the number of cars leased will vary by about 1.14 cars. And always use units of measurement when you can. Again, it shows the reader that you understand what you are finding. Okay, we get a $500 bonus for a car sold, $300 bonus for a car leased. Find the mean and the standard deviation for the difference in the bonuses. So this is mu sub BD, bonus difference. So 500 times the mean for selling cars minus 300 times the mean for leasing cars. And I got $340. And then sigma sub BD, so this is the bonus difference. Okay, now make sure that you understand what's happening here. I am taking 500 and timesing it by sigma. I am squaring that whole thing. Then plus, because we always plus regardless of whether we're finding a total or a difference, 300 times that sigma, whole thing squared. That's going to come into play quite a few times about multiplying the standard deviation, and make sure that you multiply it before you square it. And that gives me $509.09. So typically the bonus difference will vary by $509.09. All right. Mr. Starnes likes sugar in his hot tea. From experience, he needs between 8.5 and 9 grams of sugar in a cup of tea for the drink to taste right. While making his tea one morning, Mr. Starnes adds 4 randomly selected packets of sugar. Okay, I already can see it. Packet 1, packet 2, packet 3, and packet 4. Suppose the amount of sugar in these packets follows a normal distribution with a mean of 2.17 grams. That's per packet. At a standard deviation of 0.08 grams. What's the probability that his tea tastes right? Well, I can already see that I want to do a normal CDF from 8.5 to 9. I need the mu and the sigma, because 8.5 to 9 grams is what's going to make his tea taste right. So I can already see that's what I want to do. But I need to find the mean and the standard deviation of all 4 packets. And I'm going to let you know, a couple years ago, there's a problem almost exactly like this, and it was a full FRQ on the AP exam. So here we go. I am going to let X equal amount of sugar in random packet. Now I have 4 packets. That's packet 1, packet 2, packet 3, packet 4. So I have X, which is defined as the amount of sugar in each packet, but I have 4 packets. So I have these sub numbers, kind of like when we played the roulette wheel. We had the first turn and the second turn. Okay, so you can't just have an X. You got to show all 4 packets. Okay, I'm also going to define the letter T, because T is the total amount of sugar. So mu sub T is going to be defined as mu sub 1, mu sub X sub 1, mu sub X plus sub 2, mu sub X sub 3, mu sub X sub 4. So mu sub T equals, and it told me that each one was 2.17. So mu sub T is 8.68 grams. Again, units of measurement. All right, so I now have him. Okay, so now I need sigma. So sigma sub T is the square root of sigma sub X sub 1 squared plus sigma sub X sub 2 squared And they were all 0.08. And I would pause this and I would type this in and make sure that you can get this on your calculator. All right, so now I know him. Well, anytime I normal CDF, I'm going to draw a picture. I'm never going to normal CDF and not draw a curve. So he is good. All right, now see, my average for the total was 8.68. So I'm just going to put that there as a reference point. And he is good if it's 8.5 all the way to, is it 9? Yeah, all the way to 9. So right here's the sweet spot for his T. So I'm going to normal CDF from 8.5 to 9 with my mean of the total, because this 8.5 is the total amount of sugar in his tea. So 8.68 and 0.847. Type that in and you get, no, not 0.847, sorry. That's not sigma. Sigma is 0.16. So sorry. This answer is 0.847. Therefore, there's an 84.7% chance that Mr. Starnes' tea will taste just right. Okay. All right, last problem. Here's my challenge to you. I challenge you to pause this and go as far as you can with this problem without me. Read it, digest it, label, do some stuff, think about an AP grader, and then hit play when you're done or hit play when you're stuck. A diameter C of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inches. Okay, so C is the cup diameter, and mu sub C is 3.96 inches, and sigma sub C is 0.01 inches. The diameter L of a randomly selected lid follows a normal distribution with a mean of 3.98 inches and a standard deviation of 0.02 inches. Okay, so it makes sense that the lid is a little bit bigger than the cup diameter, but you don't want it to be too much bigger. There is some variation going on here in the cup and the lid. For a lid to fit on a cup, the value of L has to be bigger than the value of C, but not by more than 0.06 inches. What is the probability that a randomly selected large lid will fit? Okay. Has to be bigger, but not by more than 0.06. All right, so it sounds like we're subtracting, because I want the difference between the lid and the cup to not be any more than 0.06. So what I think I want to find is I want it to fit perfectly, or it can go to 0.06 of the difference of the difference. So it can't go smaller than that, because then the lid, it can't go negative, because then the lid will be smaller than the cup. So there can be no difference. It can fit perfectly, or it can go up to a 0.06. So I need to find D. D is going to be lid minus cup. Lid, because I want the lid to be bigger. So then mu sub D is mu sub lid minus mu sub C, which is 3.98 minus 3.96, which is 0.02. So I have just found that guy. And I'll draw my curve here in just a second. Now I want to find sigma. Well, sigma sub D is the square root of the variances. So 0.02 squared plus 0.01 squared. I strongly recommend making sure you can type that in correctly. All right, so let's see. That is my mu sub D, so 0.02. And then I can go from a 0 to a 0.06, and it'll fit. So I'm finding the probability, and this is D, that the difference is between a 0 and a 0.6, and that's what this is going to find me. And I get 0.777. There's a 77.7% chance that a randomly selected lid will fit on a randomly selected cup, which means 22% of the time they don't fit. Think about that. Okay, now if that was a lot writing and thinking at the same time, then I strongly recommend that you go back and just listen to that problem one more time. I think it is very beneficial to think here, kind of here, and maybe here before you dive into the mu sub D and the sigma sub D. Like think about, okay, what is it I'm trying to find and what do I need to get there? So I knew that I wanted to be between a 0 and a 0.06. I knew I needed the difference between the two, so that's how I knew it was a difference, and just make sure you define all your variables. Lots of tiny little details on this stuff, but I don't think it's significantly hard. There's just a lot of nitty-gritties that you have to be aware of, so just be careful.